Hello, Math 3 students. Today we're going to be going over solving rational equations. So basically it's very similar to adding and subtracting rational expressions, but there's kind of just like two added steps. So it's not too much more challenging than what we've already learned. So just like before, our first goal here is going to be to get a common denominator. So looking across here, this guy's got an x minus 3 in the denominator. This guy has an x minus 3 in the denominator. This guy just needs an x minus 3, right? So I could multiply the 1 by x minus 3 over x minus 3. Just distribute the 1, which doesn't really do much. But I end up with x over x minus 3 plus x minus 3 over x minus 3 equals 7 over x minus 3. So now at this point you can see that I have a common denominator across the board. So what I recommend you do at this point is check for which values x cannot be. Now if you recall, in math, denominators cannot equal 0. So basically at this point, once you have a common denominator across the board, take your denominator, set it equal to 0. So if we do x minus 3 equals 0, we get x equals 3. So that means that x cannot equal 3. Okay, this is very important. So when we go to solve this equation, if our only solution, or if one of our solutions is 3, we have to x that out and it is no longer a solution because it cannot be a solution because it's not part of the domain, because it makes the equation undefined. So this is an important part here of determining which values x cannot be. Now, once we've found out what the values that x cannot be, and we've got a common denominator, we can essentially just get rid of our common denominator, okay? So when we do that, we end up with x plus x minus 3 equals 7. Now, this is just a simple equation at this point. We just do 2x minus 3 equals 7, add 3. We get 2x equals 10. We end up with x equals 5. So once I get my solution or solutions, I have to go back and look. Okay, well, x cannot equal 3. I end up with x equals 5. That's a good solution. So that's what I would plug in as 5. All right, next one. So if we look here, again, we're going to have our common denominator of x minus 1. The only guy that needs an x minus 1 is going to be this 8. So I'm going to do 8 times x minus 1 times x minus 1. Now, don't forget to distribute. So I end up with 8x minus 8 all over x minus 1 plus 1 over x minus 1 equals x over x minus 1. All right, so now we've got our common denominator. Don't forget to check which values x cannot be. Looking here, x cannot equal 1. So make note of that. Now we can drop out our denominator, and we end up with 8x minus 8 plus 1. Now, you have to distribute this, right, to everything here. It's a plus, though, so you don't have to worry about it. However, sometimes you're going to end up with a minus in there, and you have to make sure that you distribute it to everything on the top of this fraction here. All right, so we can go ahead. We end up with 8x minus 7 equals x. I could do minus 8x minus 8x. I get negative 7 equals negative 7x. Oh my goodness, divided by negative 7. I end up with x equals 1. Now, if you notice, this is a problem, right? Because once we got our common denominator, we determined that x, in fact, cannot equal 1, right? And we ended up with x equals 1. So I should say we ended up with x equals 1 is our only x value that would satisfy this equation. Because of this, we end up with no solution. Or sometimes that's shown as this. I'm pretty sure on Delta Math, you just literally submit nothing. Like you just click enter and it submits. So yeah, so that is what you do when you end up with an x value that isn't going to work. All right, so we look here. We got to determine what is our common denominator. That is going to be x minus 1. So I got to take my 1, multiply it by x minus 1 over x minus 1. So I end up with x minus 1 over x minus 1 plus 8 over x minus 1 equals 8x x minus 1. All right. Is this the same? It's a very similar problem. All right. So again, x cannot equal 1, right? Because that would make my denominator 0. Again, you get that from taking the denominator, which is x minus 1, setting that equal to 0, and figuring out what values would make that equal to 0. We've got a common denominator. Drop it out. We end up with x plus 7 equals 8x. Minus x, we get 7 equals 7x divided by 7. Again, we get x equals 1. But we said x cannot equal 1, so this is no solution again. All right, so now I'm going to point out, don't forget, we've got a negative here, so that's going to change things a little bit. So keep that in mind. So looking here, we got to get our common denominator. Our common denominator is just going to be x minus 6. So my first guy is good to go. I just got to worry about the second guy. So I'm going to do 3 over 1 times x minus 6 all over x minus 6. So I distribute that, and I'm going to end up with 3x minus 18 all over x minus 6. So we've got this. I'm going to bring down everything from the top there. I'm just, bringing that down, brought my negative down. All right. So now what we have to do is we got our common denominator. Let's determine which values of x are undefined, aka which values x cannot be. In this case, x cannot be 6, because if I put a 6 in, I'm getting a 0 in the denominator, and we cannot divide by 0. Next, we're going to go ahead. We have to distribute this. So we end up with 2x minus 3x plus 18 equals 2. And at this point, we could drop out our denominator because it's the same across the board. We get minus x plus 18 equals 2. Minus 18, we get negative x equals negative 16, which gives us that x is 16. So, of course, we've got to go and check to see if our answer is any good here. And fortunately, it does look like it's pretty good because x cannot be 6. We've got 16, so our answer is just 16. All right, let's keep rocking and rolling here. So number 55, all right, let's determine what our common denominator is. In this case, it is going to be x plus 2. So I'm going to take my first guy. He doesn't have my common denominator, so I'm going to do x over 1 times x plus 2 all over x plus 2. All right, so then what we can do is go ahead and distribute my x. I get x squared plus 2x all over x plus 2 minus x all over x plus 2 equals 2 all over x plus 2. All right, so at this point, we've got our common denominator. This is when I recommend you determine which values of x are undefined. So in this case, x cannot equal negative 2. All right. So we can go ahead and start solving this. Drop out our denominator. We get x squared plus 2x minus x equals 2. All right. So we can combine like terms here. We get x squared plus x equals 2. And it's like, oh no, we've actually got a quadratic here. How do I know we have a quadratic? We've got an x squared term. So far, these have all been linear equations. But at this point, we got to start solving a quadratic. So if you recall, to solve a quadratic, you want to get all of the terms on the same side. So I'm going to subtract 2. And I end up with x squared plus x minus 2 equals 0. All right, so I got to figure out what two numbers multiply to negative 2 add to 1. Now, hopefully you remember, there's a lot of different ways to solve quadratics. The quickest way, if you can, is to factor. So that's what I'm doing, is factoring this. If I couldn't factor this, I would need to go and use quadratic formula. All right, but fortunately, this looks factorable. I'm going to do x minus 1 and x plus 2. All right, so I then can set these equal to 0. And I get x equals 1, and I get x equals negative 2. Now, of course, I have to go back and see which values x cannot be? Well, x cannot be -2. So this solution is bad. However, we still have one good solution. So my solution here would just be x equals 1. All right, next one. We look here. Our common denominator is going to be x plus 4. All right, so I'm going to go ahead. My first term here needs the common denominator. So I'm going to go ahead and multiply this 2 by x plus 4 all over x plus 4. And I get 2x plus 8 all over x plus 4. This middle guy is good to go. This x needs it. And I end up with x squared plus 4x all over x plus 4. All right, so at this point, I've got my common denominator across the board. I know that x cannot equal -4. All right, so we're going to keep that in mind. Now I can go ahead and drop out my denominator. I get 2x plus 8 minus 5 equals x squared plus 4x. All right. I can go ahead and combine like terms. X plus 2x plus 3 equals x squared plus 4x. Again, we've got a quadratic, right? So we have to go ahead and get everything on the same side. What I recommend doing is the x squared term, keep it positive, right? So he's positive on this side. I want to keep him positive so it's easier to factor. So I'm going to move these guys over. So I'm going to do minus 2x, minus 2x, minus 3, minus 3. And we end up with 0 equals x squared plus 2x minus 3. So then I can go ahead and figure out what multiplies to -3 and adds to +2. So that is going to be x plus 3 and x minus 1. Then we set those equal to 0. I don't know why I put that in parentheses. We get x is -3 and x is +1. Now, again, we got to go look. Well, what values can x not be? Well, x cannot be -4. And if we look, we got -3 and we got 1. Those are both good to go. So we actually have two solutions here. To plug in two solutions on Delta Math, you can make two boxes by either doing the plus minus in the corner, or you could just do like -3, 1, and it'll make two boxes. But there is two answers there.